Hello everyone, welcome to Tech Time Live. I'm Jacob and this is Mark from BEA, and we are presenting the LZR-WIDESCAN today. Moderating the chat is Rob Rivera, and we also have Rebecca from sales. If you have any comments or questions you'd like to make, there's a chat box you can put them into. Rob will be answering any questions you may have, and he may even bring them up for everyone to hear. So without further ado, this is the LZR-WIDESCAN, and we are going to be showing how to install it, as well as just talking about some general info. This is going to be a three-part series. Today's the installation, the next one is programming, and the next one after that is going to be the Bluetooth app, which we do have for the second version of the WIDESCAN. So we'll go ahead and show it now. I'm going to flip my screen.
So this is the WIDESCAN. I'm going to put the cover back on so everyone can see. This would be the front of the sensor. Here's the back of the sensor. This cover on the top, there's two little tabs here. You just have to lift these tabs and the cover swings down, and then you can take it off. We're going to leave this cover off for the rest of the time. In fact, whenever you're doing an install, just take the cover off and leave it off until you're ready to go home. A couple things about the sensor. You'll see right away we have an LCD screen and some programming push buttons, so you can program the sensor without a remote control or an app. Here's where the power connector plugs in. There's a little wiring guide here to tell you what color wires do what. This is a great place, or a great way to know this is a version 2 sensor that's Bluetooth enabled. The older sensors don't have this. On the bottom of the sensor here is the lens. And inside here is where the lasers come out of the sensor. So this piece needs to be clean and clear, no scratches, nothing blocking this piece. There's an LED window on the bottom with several different multicolor LEDs. 3 adjustment screws, one on the top and one on each side here and over here. This basically, if you adjust the top one, is a tilt to get the pattern closer to or farther away from the door. The other 2 are for side to side for, if your wall's not even or you need to straighten the pattern out. On the back side of the sensor, there's a mounting bracket, 2 little dog ears here to fit our other mounting adapter on the top, and then the set screw that will hold it in place once you get it aligned.
So up here we have the mini bracket, and we're going to talk about some mounting for the sensor. And before that, you can see this cable he's plugging in, and you just put it on there and you twist it on. It's big cable. We have it running to a DC power supply. The sensor is AC or DC, which makes it different from all of our other lasers. The other ones can only do DC. This does AC or DC. Now, the mini bracket here, it goes about 1 foot out from the door. And what makes it good is if you have a door like what I have that rolls up, it goes up onto the ceiling, you can't make it a center mount, which is a center mount or a left mount. So this sees past the door at the upper left corner.
You see we have this extra piece of plastic on our bracket. This is called the WIDESCAN adapter plate. And you need this to mount it. All of our brackets are this, but the WIDESCAN mounting bracket it comes with has this 3 points. So we really needed the extra adapter here to get to our points. This part number is like 10.1311, but you have to drill the holes bigger in the metal bracket, and then the screws come in from the back side. This plate plastic is threaded, so that's what's holding this on here.
Yeah, so he's putting the adapter plate on now, which basically is just 1 screw on the top, 2 screws on the bottom corners. And this is what's going to hold the WIDESCAN in place. So we have it at about 6.5 feet right now, maybe about 7. That's the absolute minimum, is 6.5. And you can put it pretty high. What is it, about 30 feet now? So anywhere in between. And a little bit more on that is to know how far the field goes on the sensor. It's the height times 1.2, just about. So let's say you have a 10-foot height, times that by 1.2, it's going to go 12 feet out, 12 feet wide. And you can't go any further than that at that height, but you can customize it to be smaller.
If you were going to do a center mount, I'm going to bring this over here. You guys are probably not going to be able to see these red dots, but this sensor has visible alignment lasers. If you press the OK button twice, you'll see it says red spots on. You can do this with the remote control too, but you get 2 laser spots. I'll try to hold them real still. It's hard to see.
You should be able to see them here.
If you mount in the center of your opening, the only thing you have to do to align that is make your spots that you turn on be centered in your opening. If we go to the left-hand side, we have to do one extra step, which is why we're on the left over here to show you the positional wizard. Let's see, I'm going to make this adapter fit into those little dog ears. I turned it almost all the way counterclockwise, so it's pointing to the right, and then it spins clockwise and locks on.
And you'll see there's a blue LED under there. That's for the Bluetooth. That's also signifying it's version 2, not version 1.
At this point, all you want to do is hold the OK button in until the display changes. It takes about 3 seconds. When you're done, it's going to look something like that. Once that comes on, we're going to, again, adjust those spots by physically turning the sensor on that bracket until our spots are centered in the opening. Once that's done, I'll press OK again. And now you'll see the display change one more time. It's giving us an arrow that's flashing and telling us which way to bring the sensor back to. So as I start to bring the sensor back a little bit, the top arrow will move back and forth, and we want to line it up with that middle caret line. And it's kind of sensitive, so you got to play with it a little bit. Sometimes it's good to line it up and give it a second. Once it's good, press OK again. And at this point, we're going to take this set screw that we talked about earlier and run that all the way in. And that will keep this from spinning anymore on the bracket, and it'll keep our pattern centered in the opening.
And you'll see now that he did that, there's an orange LED underneath, and that means it's looking for an install teach-in. If you look at the screen, you'll see a graduation cap, and it says install. Now, we're going to do this by remote. And first of all, what you always do, and we have a Tech Time Live with the remote, so if you want to reference that, please do go ahead to learn it. But you always start by pressing the unlock button on the remote. And when you do, you'll see on the other screen, there's a red LED blinking very slowly. That means it's unlocked. And if you look at the screen, there's an unlock symbol. So everything you say in that remote will show on the sensor to confirm that it took your setting. Once you press unlock, the magic wand symbol on the very bottom right of the remote, that's to do a teach-in. And you'll see on the sensor, LED went faster, and it shows the magic wand symbol. Now for the next one, you're going to hit the number 0. You're going to see red, green, and step out of the way. This is going to confirm the teach-in. So you have 10 seconds, maybe a little sooner when you do it by remote. You're going to see it goes from an hourglass to a triangle to a down arrow whenever you're up by the sensor, or if you can see it by where you're standing when you're installing. It's going to do a check mark, and all the LEDs go away. Of course, it sees me right now. For what you can see in the other screen, all you have is blue. If I walk up to it, you'll see green, red, flashing red. Now the sensor has 3 relays, and these relays are customizable. And this is the screen you'll see at default. It has motion, presence, safety, and actually pull cord. But we won't go into them too much during this presentation. There will be more. And along with, and that's a basic install, what you just saw without the programming, but we're going to go over one error that we usually have, and that is a flatness error. And what we're going to do to replicate that, I'll grab this chair, is we're going to put some stuff in the opening. So put a chair there, put a box, and actually to confirm that we get this error, I'll stand in the opening. And then Mark's going to do another teaching, the unlock magic 10, and it's going to see everything in this field. What makes this so important to know is the flatness means the ground between the dots and out maybe 6 to 8 feet is not flat. It will, and don't think that curved surfaces matter too, because ramps work and just flat ground. But
it's
it
really
has to be
more
clear.
to deal with making sure the ground is totally flat and there's nothing in here like this. Of course, we passed the lunch. Let's try it right here.
So I'll walk around a bit. You want to make sure your field is clear when you're doing teaching. If it's not, you should get the error. So we got it. And I'll go up close to the sensor. You're going to see it says E5 flatness.
Also, the orange LED will be flashing 5 times, letting you know that it's in error.
So once we move everything and you make sure that your field is clear, you do another teach-in. And you can do it from the sensor, but I would do it by remote because you have a faster chance of getting down to the ground.
When you launch the learn from the sensor, it's a 60-second timer before it starts. So if you're on a lift or on a ladder and you don't have a remote, no big deal. You can launch the learn from the sensor and then move everything out of the way. You get 60 seconds. From the remote, you get 5 seconds to get out of the way. So it's a little bit faster of a learn time. And now we've cleared the error. So most commonly in the field, you'll see a flatness error when there's like a drain, something that runs maybe all along the floor here, a small floor drain, or maybe something right in the middle, a big floor drain, or maybe even on the exterior side, it might be a dock lock or something like that. To pass that or to get through in those situations, probably 90 out of 100 times laying cardboard down and just covering the holes is all you need to do. Sometimes you have to go to a little more, you need to get something a little more substantial. I think Jake had a call today where they used some sheetrock actually on some asphalt that was really cracked. So sometimes you need something more than cardboard, but this is not a problem you'll see frequently.
Right. And really, that's the installation of the WIDESCAN and an error. So if you have any questions that you'd like to say now that haven't been answered yet, or if Rob, is there anything that's been going on in the chat?
We have just like some other common examples of flat floor that may cause an E5 error, like maybe some job site examples. What about floor drains? Changes in the changes in the ground conditions that could potentially cause this.
I think one of the first ones I ever saw was a wheel washing. It was like almost like it was a little dip that forklifts drove through and it washed their wheels off. And it just happened to be when we set the WIDESCAN up that it ran right through the middle of our pattern, and we've got flatness every time. So we lay some cardboard down or something to cover that dip up, and then we can pass the learn. But I would say most common are drains. People just simply not getting things out of the way, either like your toolbox or a ladder, or if I'm standing right here, well, you can't see me, but if I'm standing underneath the sensor and trying to do a learn, I'm going to get a flatness error because I'm in the way.
Yeah, and people in the field is a really common thing. And even if you think you might not be in it, I just take a few more steps back to confirm.
What about it's been mentioned in the chat here that you're mounting on the left, what about a right mount?
That's a great question. I think that early on when we got the sensor, the message was always never on the right hand side. It's best on the left, and then we can put it in the middle if you need to. And then that changed, and they said, no, middle or left, everything's good. And then shortly after that, they were talking more about right hand installations. I'm going to say there's probably a dozen that I know about on the right hand in North America, and I haven't seen any issues yet. If you want to mount it on the right, I'd say give us a call and let's talk about the application, because so far I haven't said no to anything yet. I think mounting on the right's okay in some circumstances, but you lose some performance on the sensor. It doesn't look out quite as far as it does center or left. So on small doors, maybe that's okay, but we're still looking at it a little bit.
What else we got?
So let's hear. Is the sensor suitable for outside alternate weather? What do you have?
Yeah, absolutely. It's a great product to put outside. You know, I put it right up there with the Falcon as far as harsh environments. The sensor's okay, and it has a heater that's built into it, so you can turn the heater on and it stays warm and keeps the lens from freezing over in the wintertime. The laser is what makes it so good for outside.
Of course, the heater has, just so everybody knows, it has three settings. You might want to touch on that a little bit, but also a very good question is the power requirements on this sensor.
So the sensor by itself, sorry, if you want to jump in here anytime, go for it. But the sensor by itself is 12 to 24 volts, AC or DC. It's one of our only laser products that's AC or DC, so that's kind of a nice feature. And it's actually really low power. It's less power than a Falcon, actually, once it's powered up. So it's 2.5 watts is what the sensor uses. Now, if you want to turn the heater on, the heater adds 15 watts. So at 24 volts, if you turn the heater on, you're talking about 650 milliamps of current, whereas under normal circumstances, you're talking about like 80 milliamps of current. So that's at 24 volts.
You have to use the plastic piece to the sensor fits the dog ears you mentioned. Can I simply install the sensor itself onto a surface?
Oh, no, you can mount directly to the surface. Using that little dog-eared piece gives you the most adjustability. It lets you really rotate that sensor on the bracket. So if you need to change the centering or the area at all, it's good. It's great for me because it's very forgiving. You know, if you put that piece up, if it's not square or if it's not exactly at the right angle, it doesn't really matter because there's a lot of adjustability built into that bracket. But you can screw the back piece right to the wall, especially if it's a center mount.
Right, and along with the brackets, I didn't mention this. So we showed it on the mini bracket. This is the industrial bracket. It can go about 3 feet out from the door if you need to go that far.
So
And
for
does have a negative tilt angle if you want to tilt it back more.
that would be for goalposts or something where you want a left mount off to the side. Also, freezer applications and dealing with condensation and air conditions. What alternate air conditions of condensation and such.
I've found that the WIDESCAN is really good where it's cold, but it does see fog sometimes, especially if it's heavier. So if you're dealing with a refrigeration or a freezer type situation, if you have one side of the door that's not conditioned at all, I think it's pretty likely to see problems based on humidity. But if you have a lot of moisture on one side of the door and very cold on the other, just like at your grocery freezer, if you open that freezer for too long, it builds a lot of fog. The sensor can see that if it builds too much. So outside of that, it works really well in those environments.
And that seems to be about all the questions that we have at the moment.
We had one from the Q&A section, Rob, that says, how long does it take to install this?
You know, that's a good question too. So most of the people that I talk to, their first time around, takes them a couple hours to really get the feel of it. Training beforehand smooths that out quite a bit. But the more experienced installers that have done, you know, maybe a dozen or more of these, seem to get faster and faster with everyone. And they tell me that it takes about the same time as it does to install a Falcon.
And I would add to that the job site conditions, pulling the cable usually is, as you can see, Mark and Jake actually did an install before our eyes. So there's not too much to the install. The setup is another process. The wire pull usually takes the duration of the time on a job site, really. So if you have conduit, it's going to be quick and easy. If you have to run your wire over surface applied, it's going to be relatively easy. If you have to conceal or anything, that's a separate issue, but it is part of the job. So those conditions matter.
I guess one thing that is important to mention is that, you know, Falcon can be plugged in and screwed to the wall, and you can walk away from it and it's operational. The WideScan does require a couple extra steps. You know, you got to get it lined up. You have to do a learn with the remote control. And at that point, you can program dimensions and make your field smaller if you wanted to, but it's not necessary.
We got a couple other good questions that just came in. One is, you mentioned this sensor tilt angle. What is it? 10 to 5 degrees. Let's see here. And then also, does it have monitoring?
It does have monitoring. There's, it's built in.
That tilt angle, what we were shown at the beginning, is adjusted right here. So when it's tightening the sensor or it's loosening it, as you can see with the little threads here. And when you tighten it or loosen it, your sensor is going like this. And your red dots are moving depending on how you tighten that screw.
And we have another question that's a very good question. Would it splice to hurt to splice the wire length for whatever reason? It may not be long enough. No, this device is kind of a standardized sensor where you have two wires providing power. And of course you can splice power. We do it all the time with any device that requires power. And then the others are relays, so they make and break. You know, there's a table in NEC for extending drastic lengths and looking at the voltage drops, table 9 and chapter 8 of the NEC. But I mean, other than that, if you're within probably, I would say 400 feet, 500 feet, you could extend this and splice into it without problem. We've had some excellent questions in here, really excellent questions. Another question.
Anything else in there?
There was one via the Q&A that said, what's the worst environment you have seen the sensor installed in?
Well, really outdoors where everything was frozen all around it except for the sensor was the only thing that wasn't frozen because the heater was on. It was a freezing rain condition where it was outside, and literally the door, everything else was covered in a couple inches of ice, but the sensor right up until the top of the cover was totally free. So I thought that was cool. The worst scenario where the sensor just wouldn't perform was it was a food distribution facility, and it was so foggy that I couldn't see from me to Jake away. And it had no hope of operating there.
Another question that just popped in is, how does snow on the ground affect it? I'll go let you answer that, Mark.
Well, you know, that's part of what makes the laser technology so great is the present sensors before relied on the ground to get a signal back to it. So of course, when the ground condition changes, that would put the older style sensors in detection. Laser doesn't even look at the ground. After we do that one learn where we look to make sure the ground is flat, this sensor never looks at the ground again. In fact, it is automatically backing up about 6 inches off the ground. It was like 2 feet on camera there, but it doesn't even look below that anymore. So snow on the ground, unless we're talking about blizzards and you're getting feet and feet of snow, then it's not an issue. You know, with an IS-40 or infrared technology, snow's a huge problem. Even we have light colored concrete here today. If we dumped a bucket of water on, it would be dark. That might put an infrared sensor into detection, whereas the laser wouldn't even know that it happened.
That seems like all the questions. And again, we've had outstanding questions.
Yeah, we really appreciate the feedback and the comments and questions everyone's been putting in. I guess we'll end it here then. Thanks for watching this Tech Time Live. If you have any recommendations, please do feel free to tell us. Expect 2 more about the WIDESCAN, 1 for programming, 1 for the Bluetooth app. And that's it. Just thanks for watching. Come again next time.